Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with the different subjects ranging from mathematics, physics, chemistry and biology and other application areas. So today we are going to look at the concept of exterior angles, and this is going to be a complementary video on geometry, which is going of course to assist us in trying to describe various aspects of a triangle insofar as angles are concerned. So in this particular case, I'm going to describe the various characteristics or the various aspects of exterior angles using an illustration that I'm going to have on the board. So we see that a triangle basically is going to consist of three sides or three vertices, which are going to be non-collinear points. So if I have angle A, B, C, or rather, let me just put this one as that. So it's going to be angle ABC. So this is going to consist of three collinear points, which are A, B, C, and therefore we say that this particular triangle is going to constitute the interior angles of A, B, and C for those respective vertices. And we can be able to give this one, of course, another additional statement for this. So we're going to include this one. I've just done this stretch intentionally so that we can be able to just have a discussion on this. So I've just illustrated this one to show that these angles may be the same or different. So this one is going to be referred to as an exterior angle. And this particular aspect, let me give it alpha, beta, and theta. So this alpha, beta, and theta are going to constitute interior angles. And this one is going to constitute perhaps, let me give this one as omega. So omega is going to constitute an exterior angle given as such. So we can be able to give various characteristics of this interior angle in relation with this exterior angle of a triangle, whereby we see that beta plus alpha plus beta are going to form 180 degrees. But from this one as well, we can be able to have a conclusion that, let's say this is a point R, and the point RAB are collinear in a sense that they lie on the straight line. Therefore, we can be able to describe omega and alpha in terms of omega plus alpha is going to be 180 degrees given as such. So that therefore from this specific conclusion, we can be able to see that if we do a substitution for, of course, omega, then therefore we can be able to describe omega, which is the second part of the equation in terms of the first one, whereby omega is equivalent to 180 degrees minus alpha. But from our first equation, so this is equation 1, and then we can develop another equation, which is equation 2 from the equation, the first one. Let's refer to this one as A and B. So the first one, omega is equivalent to 180 degrees minus alpha degrees. This is equivalent to, this is a derivation of equation B. So from equation A, we can be able to also make a conclusion that alpha plus, this is so alpha plus omega, alpha plus theta is equivalent to, so let me just make a, okay, sorry for that. So we are going to make a conclusion that therefore that we can be able to describe this specific aspect of alpha from the first equation A, whereby we are going to have alpha represented as 180 degrees minus. So we take this one the other side, which is omega plus beta given as such. So if we try to look at this, then therefore the 180 degrees minus alpha plus beta is going to imply that this is a description for alpha. But as well as we say from this, so this is going to be our equation 2. So as we said from this one, also including omega, we can be able to describe alpha in the same manner from equation B, whereby we are going to have alpha as 180 degrees minus omega. So therefore we can be able to equate this particular equation number 2 together with equation number 3, whereby we are going to have this one as 180 degrees minus omega, which is equivalent to alpha, is also equivalent to 180 degrees minus theta plus beta given as such. So if you try to do a rearrangement of this specific equation, we can take this one the other side and have it, or bring this one 180 degrees to this side, and then take the omega to the other side minus theta plus beta given as such. So this is going to be 0 is equivalent to omega minus theta plus beta given as such, implying omega is equivalent to theta plus beta given as such. So in this specific case, if you try to look at a triangle, then therefore alpha and beta, omega, this is going to be theta and beta are going to be referred to as interior angles, and in this specific case, these are going to be referred to as remote interior angles. So we can be able to see from our evaluation that basically the addition or the sum of the remote interior angles are going to be equivalent to this exterior angle that we have given for omega given as such. So for n triangle, that is the measure of an exterior triangle is going to be equal to the sum of our remote interior angles. And of course, this is going to be a theorem that is going to apply for exterior angles and other areas of application that we have just illustrated as this. So this one, in collaboration with other areas we are going to come across, is going to assist us in trying to evaluate this specific aspect of the exterior angles. Now, using this specific theorem that I've just been trying to evaluate, and therefore we can be able to conclude that the addition or the sum of the remote interior angles is equivalent to, of course, the stretch or the angular stretch of this specific exterior angle that I've given in terms of omega. So that is it. So catch us in our next video as we're going to look at other areas of trigonometry, and I'm going to put a link of this specific description, of course, discussion in the description box in terms of a playlist. So kindly open and check other videos which are related to this one, so that you can be able to have a comprehensive understanding of these various aspects of geometry. So that is it for now, guys. Bye. God bless you. Catch us in our next video.